In this lesson, we're going to talk about how to factor anything. And when you're given a polynomial and asked to factor it, you can always use guess and check if you have a lot of time. You can always use logic, which is a decent strategy. Or you can use this method that I'm about to describe to you called the grouping method. Now, what the grouping method requires is that one, of course, you really understand how to multiply polynomials, and two, a polynomial with enough terms that can be broken up into smaller groups of equal size. So in this case, I have an expression with 4 terms, or I can think of it as 2 smaller groups of 2 terms. And what I'm looking for is what these 2 groups have in common factor-wise. So if I just look at this first group and I think about what its GCF is, well, the greatest common factor between AC and BC is C, and I'm left with A plus B. And then if I look at this group and I think about its GCF, well, its GCF is D, and what I'm left with is A plus B. Now this expression here is identical to that expression up there, the original one, but it's written differently. The pairs had their GCFs taken out. Now if I look at these 2 pairs and see what these 2 pairs have in common, they both have an A plus B in parentheses. So one factor of this expression is A plus B, the other one's C. And one factor of this expression is A plus B, the other one's D. And what do these 2 chunks or groups have in common? Well, they have the factor of A plus B. What did A plus B get multiplied by? Well, it got multiplied by C, and it got multiplied by D. So this A plus B is what these 2 groups had in common, and these were the GCFs. And if I think about where the multiplication comes from, so if I go backwards to see where I got each of these steps, well, I multiplied C times A and C times B, which is that. And then I multiplied D times A times D times B to get that. And so when I actually do the multiplication, I get those 4 terms. So the grouping method quite literally takes the multiplication of a binomial times a binomial and undoes it one step at a time. So to offer another visual representation of this, let's think about geometrically what this multiplication means. If I put these 4 terms into these 4 boxes, AC, BC, AD, BD, and if I look at each of the rows and each of the columns and think about what the GCFs of the columns and rows were, well, this column's GCF is C, this column's GCF is D, this row's GCF is A, and that row's GCF was B. And so where do these 4 blocks come from? They come from A plus B times C plus D, which is exactly the same as this thing here. I just reversed the orders of the factors. Now let's do this example. I'm going to stay away from the regular old polynomials for a second, just to illustrate a point. I want to factor this, and I have 4 terms, so I'm going to group them into 2 groups of 2, and I'm going to check and see if I factor out a GCF of each group, if I get left with the same thing in the parentheses. So in this case, the GCF is A, and I'm left with a D plus a C. Now when you want to do factoring by grouping, there's something that'll guide you, and that's what's in the parentheses here. If you can factor by grouping, and if you can factor it, then what's left over in parentheses of the second group has to be identical, or the grouping fails. And so then I just have to think, well, I have D plus C, but I originally had minus D minus C, so what did I have to factor out to get that to be a positive D and a positive C, when originally it was a negative D and a negative C? Well, if you remember back to the GCF video, I said if you wanted to change all of the signs, you had to factor out a negative. So in this case, if I factor out a -1, I'm going to get the signs to be a plus D plus C. And so the final step for grouping is to combine those two parentheses into a single set, and then to take the GCFs, which in this case were A and -1, and put it in a second set of parentheses, and there, that's factored. So for the second example, I have this expression. It's not simplified, it's got parentheses in there, and of course, if you wanted to, you could simplify, but I'm not going to, because the whole point of factoring by grouping is that I'm looking for a factor in parentheses that's in common to both groups. So it's like I have a group here and I have a group there, and what's in common from both of these groups is the factor of x minus 4. So one of my factors was x minus 4, and then I take the leftovers, the 3x and the plus 2, and that makes my second factor. And realizing that your factors can themselves be polynomials is actually a big help. So if you recognize, hey, that's common to both, well, that's the greatest common factor. Now let's factor this polynomial by grouping. If I look at it, I see that I have 4 terms, which means very likely that I'm going to have 2 groups of 2. I'm just going to look at each pair without rearranging anything. Now, if you try to factor by grouping and the groups you made don't work, then try rearranging the terms a bit and then seeing if it works. I haven't had to rearrange anything yet, and usually you don't have to. So let's try this example and see if I have to rearrange anything. So if I look at my first group, 3x squared minus 4x, my GCF of this group is an x, and I'm left with 3x minus 4. Now, if this original polynomial was factorable, and I have the right groups to actually factor it, then what I have to be left with in the second group in parentheses better be a 3x minus 4. So now my job is to think, well, what do I have to factor out of -6 plus 8 to get a 3x minus 4? And so I always just look at that first term and think, well, what multiplied by 3x gives me -6x? Well, that's a -2. And then I check to make sure it works with the second term. So -2 times -4 is +8. So yes, that is the correct number to factor out. So I'm halfway there. I see that I have a 3x minus 4 common to both. So I have 3x minus 4 as one factor. And then my leftovers, x minus 2, make up my other factors. Now, one quick note. 3x minus 4 times x minus 2 is exactly the same as x minus 2 times 3x minus 4. There's no difference. I just use the commutative property to rearrange them. That's all. You may have noticed that every single example I gave you before had 4 terms, and we ended up factoring them into 2 binomials. And sometimes you're not given 4 terms. You're actually given something that's been simplified, like this example, that has 3 terms. And so if I want to make equal size groups here, well, I can have 1 group of 3 or 3 groups of 1, neither of which help me. But if I think about where this 13x came from, this 13x came from me adding 2 terms together that were like terms from the multiplication. Remember, if you do FOIL, it's the outer and the inner multiplication that add together to give you that 13x. So really, the step before this in multiplication was an uncombined 13x. It was something x plus something x. And if I can figure out what these 2 terms were, then I can factor this thing by grouping. So I need to figure out how to split up 13x. Now, when we had the very first day of factoring, we said, well, factors of 15 of C that added to B. Well, that's when this term was 1x squared. But when it's 2x squared, it's a little bit different. I can't just think about factors of 15 that add to 13, because that 13 doesn't just come from 15. It comes from the 15 and the 2. So if I were to use logic with this, then what I have are 2 things in parentheses, right? and that these first two terms, when multiplied together, gave me 2x squared. And the only way to get that is to have a 2x and an x. And then I have, well, everything's positive, so I have a plus and a plus. And then all I have to do is figure out what goes there. And this could be a 1, a 3, a 5, or a 15. And this could then be a 15, a 5, a 3, or a 1. And then I just have to figure out which combination of 1, 3, 5, and 15 goes there to give me a 13. So you can run through each of them if you want to and sort of test them out. But I'm not going to do that. I'm going to show you a different technique. So here's the technique to figure out how to break up that linear term in the quadratic trinomial so that you get 4 terms. And it's just a slight alteration of what we did when that was 1x squared. But with that 2, it changes to this. It changes to factors of the product AC that add to B. And if you only remember one rule, remember this one rule. Because in the other example, A was just 1. So I'm looking at the product AC and then which factors of that add up to B. And the reason why it's A and C is because that 2 contributes to that 13 just like the 15 did. So I take 2 times 15, which is A times C, and that's 30. And now my job is to figure out what factors of 30 when added together give me a 13. And if you don't see it immediately, then mentally run through the factors. Is it 1 and 30? Is it 2 and 15? Is it 3 and 10? Well, actually it's 3 and 10. Because 3 times 10 is 30, but 3 plus 10 is 13. So what this means is that one of these x's was a 3x and the other one was a 10x. Now it doesn't factor it for me. All it does is it tells me how to split this up to factor by grouping. Now at this point, you can do it like I did every other example by writing it out with the 4 terms, taking these 2 terms together and those 2 terms together, finding the GCFs of each of these, and the GCF of 2x squared plus 3x is x, and I'm left with 2x plus 3. So that means that on this side, I have to be left with 2x plus 3, and then I just have to work backwards to think, well, what times 2x gives me a 10x, and that's a 5, and so then 2x plus 3 is common to both, and the leftovers are x plus 5. And if I want to double check this, I can. I can type this into my calculator as y1, and I can type this one as y2, graph them and make sure my tables are identical, or I can just quickly multiply this out. Now, if you don't like doing it this way, you could also do the squares, because as soon as you figure out how to split this term up, then you put each piece into a square, and then you find the GCF. So 2x squared plus 10x. If I look at the GCFs of this column, it's a 2x. If I look at the GCF of this column, it's a 3. And if I look at the GCF of this row, it's an x. And the GCF of this row, it's a 5, which gives me x plus 5 and 2x plus 3. So the key is figuring out how to split up the middle term. And without this, I have a lot of combinations. There are infinitely many numbers that add up to 13. But this is the key, factors of AC that add to B. So for your check, I want you to factor these 5 expressions completely.